is raw data. The mean is 5,000. So it's always good to, if you're given a raw data, you can check your answer when you finish. The standard deviation is 150. So I want to get the accurate answer here. Therefore, area between 4,850 and 5,300 is 81.86%. So if I look up here now, the area is in decimal, but I can always be told to change it to percent. So the area in percent is 81.86%. 81.86%. Okay, so this is 4,500. If I move up a little bit, I can find the area between the one we did in number 1. I can always make sure that I check my answer with calculator. So it's always good to check your answer with calculator. In number 1, it is normal cumulative density function. I'm told to find the area between 10.5 and 14.5. And the mean is 12.5, and the standard deviation is 2. So I'm going to I want to check to see that my answer is correct. So I'm going to go to my calculator, and I have second verse. Normal CDF is number 2. The lower bound is 10.5. Look at the question. Lower bound is 10.5. The upper bound is 14.5. The mean is 12.5. And then the standard deviation is 2 in this particular question. So I'm verifying my answer with calculator. So it's always good to use empirical rule, but you can actually check your answer with calculator. So I am, therefore, according to empirical rule, 68% of data lie within one standard deviation, where within means plus or minus. And so this is actually almost the same, 68. My calculator is more accurate though. So the calculator is more accurate. It gives you all the decimal points that you need. So according to empirical rule, 68.27% of data lie within one standard deviation of the dog's lifespan. So 68% of dogs lie within one standard deviation of the, so 68.27. So my answer, correct to 2 decimal places, is 68.27 in number 1. So I can always use empirical rule to answer the question and then go back and use my calculator. Okay, so I said that this worksheet is in Blackboard. We're using it to review empirical rule, which we did in number 3. And in chapter 3, it's actually in our, it is in our test, which we are going to do next class. So anytime I can be told to standardize, suppose I'm told to standardize number 1. Okay, so then let me standardize. Remember the z-score. So let me standardize number 1. I am given the ordinary normal distribution. So the ordinary normal distribution in number 1 given to me is as a mean of 12.5 and a standard deviation of 2. So one standard deviation to the right is 14.5. One standard deviation below the mean is 10.5. All right, so let me standardize each of them. Remember that z-score is equal to value minus mean over standard deviation. We are trying to apply z-score like we studied the other day over standard deviation. So I'm trying to standardize. So when I'm going to standardize one standard deviation below the mean, standardize the mean, standardize one standard deviation above the mean. So let me do just that. Okay. One standard deviation below the mean is what I want to do first. One standard deviation below the mean, that's 10.5. So z-score of 10.5 is 10.5, value is 10.5, minus the mean. The mean is 12.5 divided by standard deviation. Standard deviation is 2. Okay, 10.5 minus 12.5 is minus 2. Minus 2 divided by 2 is minus 1. Therefore, this is minus 1, one standard deviation below the mean. So I can actually draw it here. And when I finish standardizing, we call this standard normal curve. So this is 1, negative 1. One standard deviation below the mean is negative 1. So the next thing I want to standardize is the mean. So now I'm going to standardize the mean. The mean is 12.5. So let's standardize the mean. And the mean is 12.5. Okay, the mean is 12.5 minus mean 12.5 divided by standard deviation 2. Mean minus mean is 0. 0 in the numerator. So I have 0 divided by 2. 0 divided by 2 is 0. Therefore, in the standard normal curve, I'll write 0 here. This tells us that the mean of any standard normal distribution is 0. The mean, when you standardize the mean, you get a 0. Now I'm going to standardize one standard deviation above the mean of the dog/pond. So that's what I'm going to do now. One standard deviation above the mean, and that is 14.5. So 14.5 minus the mean is 12.5 divided by 2. 14.5 minus 12.5 is 2. 2 divided by 2 is 1. So 14.5 is one standard deviation above the mean. Okay, you see that when I finish the standard normal distribution, I will actually get, so this is a standard normal. So a standard normal is a normal curve that is standardized with z-score. This one is not a standard normal. This is not a standard normal, not a standard normal. It's not a standard normal curve. Why? Because we're using a raw score here, but this is a standard normal. A standard normal because I standardized all the scores. Okay, suppose I am actually given a standardized score and I'm told to find the area under the normal curve. So I could be told to find the area under the normal curve when the normal curve is already standardized. If the normal curve is already standardized, I could be told to find the area under the normal curve. All right. So I have to go to the question. So let's go to number 3. In number 3, the normal curve is already standardized. So normal curve is already standardized. So whenever I'm given a question in normal distribution, I have to draw it. So it's not like numbers 1 and 2. Number 3 is standardized. So the next thing I have to do is draw a number curve. So today we are practicing number distribution. That the mean is 0 because it's already standardized. And a number at the right-hand side of the, why do I know it's the right-hand side? Because it's positive. If the z-score is positive, it's on the right-hand side. So, so now I am going to shade. I'm trying to find the area of the shaded region. So 1.28. Well, I can do this with, I can read the chart. I can read the chart, or I can actually use my calculator. So I can read the chart. But if I'm reading the chart, let me get my calculator first, then I'll read the chart. So I'm going to use my calculator and find, okay, I'm using my calculator right now and find the area. So the area between 0 and 1.28. So I can just go to second verse, choose number 2, and the lower bound is 0 because 0 is less than 1.28. The upper bound is 1.28, 1.28. And the mean of a standard normal is 0. We just said that. We verified that. And the standard deviation of a standard normal is 1. If it's a standard normal, you are counting in standard deviations. So I'm going to find the area. And that area is 39.97%. So the area of the shaded region is 39.97%. The area is 39.97%. Okay, see, I could be told to find the area under the normal curve. Also, I could be told to find the area. So now we have, let's do number 4 again. Number 4, and then find the area between 0 and, we do it again. You start by drawing a normal curve. Start by drawing a normal curve. The mean is 0, and the number given to me is on the left-hand side, 2.12. So in other words, I'm told to find the area from here to there. Now I need to find the area with calculator. And after that, I will be finding that area using by hand. Okay. So I'm going to find the area. All right. Second, distribution. And I'm number 2 because I'm looking for area. The lower bound is the smaller number. The smaller number and here 0 is the upper bound. The mean of division for standard normal is 1. So I'm going to paste and I hit enter. Therefore, the area of the shaded region is 48. Approximately, the area is 48.3%. So 48.3%. Okay. Okay, I am going to actually do do area to the right. So let's do area to the right. You need to be paying attention because this is the first time we are using our calculator to do this, but I have done this more than 3 times now. Okay, so I'm doing number 5 and number 6. Doing number 5 and number 6. So when I number 5 and number 6. All right, so I'm trying to draw a normal curve for number 5. It says area to the right of 2.4. So 2.4 is somewhere at the right-hand side of um, the normal curve, I mean the mean. So that point is 2.4 right here, but it says area to the right. It means it is area to the right side. So I don't actually know the right, but I know that the normal curve is running to positive infinity. Normal curve is going to positive infinity. So this right is infinity, but my calculator does not understand infinity. So I'm going to write 1 e to the power 99. If you want to tell your calculator infinity, positive infinity, you write 1 e to the power 99. Okay, so I'm going to pull my calculator up. And how do I answer this question? I will do normal cumulative density function. Lower bound is 2.4. Upper bound is positive infinity, 1 e to the power 99. The mean is 0. The standard deviation is 1. Okay, so now I'm going to calculate. So I'm just now going to calculate, find the area from 2.4 to positive infinity. So second distribution, and I'm in number 2 now. The number is 2.4 because 2.4 is smaller than positive infinity, and the upper bound is positive infinity. Watch it. How do I tell my calculator 1 e to the power 99? How do I type it in? 1 e second comma 99. So I just told my calculator is 2.4 from 2.4 to positive infinity, and the mean is 0, standard deviation is 1. So I'm calculating area to the right of 2.4 now, and that area is 0.002. So the area is 0.0082 or 0.82%. 0.82%, that is the area. The area is 0.82%. So I just did number 5, area to the right, where the positive infinity is 1 e to the power 99. All right, so I'm going to do area to the left. Area to the left. All right, so let me get my calculator and do area to the left. Okay, I want to find area to the left using my calculator. So I'm going to do that. Okay, so I am going to draw a normal curve. For any question on normal distribution, draw a normal curve. Okay, and -1. See, from here to here, this is, let's just make this negative 4.6. Okay, I can redraw that. Okay, now I'm drawing the normal curve associated with the question in number 6. So this is 0. The point, negative 4.6, is somewhere near 0. So negative 0.46. And I'm told to find area to the left. Area to the left, which is negative infinity, is right here. This is negative infinity. Negative infinity is represented by -1 e to the power 99. So I'll tell my calculator, this is what I'm going to type in: normal cumulative density function from the lower bound, negative infinity, to the upper bound, negative 0.4146. The mean is 0. The standard deviation is 1. So I'm about to calculate. I want to find that area right now. Okay. Okay, so trying to find the area. I want to go to second distribution, number 2. The lower bound is negative infinity because it's smaller. Negative infinity is smaller than negative 0.46. So I'm going to type that in. Negative, I'm just going to clear first. And then I'll put negative 1. Then how do I type e to power 99? Second, comma, 99. And then the upper bound is negative 0.46. Okay. And then the mean is 0, standard deviation is 1. So I'm looking for that area. I'm going to ask my calculator to calculate. So that area is 32.28%. So that area is 32.28%. Area to the left of negative 0.46, 32.28% to the nearest two decimal places. 32.28%. Because see, this time the numbers are not integers, so you are not using empirical rule anymore. But if the numbers are integers 1, 2, 3, you can actually use empirical rule, but it's going to take you a little bit longer. Okay, so I'm going to pull the charts. I'm going to pull the normal distribution chart and try to find the area. So let's pull the normal distribution chart. How do I read the chart to find the area under the normal curve? All right, so I am going to pull the chart so I can read the normal distribution. Okay, Nehemiah, I hope you're doing well. Okay, so I am going to read the chart. But first of all, let me open the chart that is in my. I'm going to open the chart. By reading the chart now. Remember, we started with empirical rule. We said we can find the area under the normal curve with empirical rule. Okay, but sometimes you are told to find the area that is you have to use your calculator. So you want to know how to use your calculator. So there is a formula sheet which I need to put. By the way, that worksheet I was using is in Blackboard. All right, so now I am going to find z-score. I'm trying to read my chart to find the area this time. All right, so I'm looking for z. So this is z-score. And I want to find the area from to negative 2.4. Let's see what that question was saying. What the question say? That question says a negative 2. What is that? Where is it? Negative 2.4. Okay, no. This is negative 0.46. Okay. If it is negative 0.46, so I am going to go back to the chart. All right. So I am looking for 0.4, and everybody needs to look. Where is 0.4 of Z chart? Okay, 0.4 is right here. So I am going to get my, okay, so this is 0.4 right here, 0.4. And 42, this is 0.40 here. This is 0.40, this is 0.41, this is 0.42. So I get the answer. That is 33.7, approximately 33.7%. So the answer will be almost the same, whether you are reading the chart or you are using your calculator. You can use your calculator or read the charts. Okay, now let's go back to the question we already answered. we want to find the area between using the charts. We have already found the area uh, by using the calculator, by using empirical rule, which means there are three things you can use. You can use an empirical rule, you can use your calculator. So suppose I'm told to find the area between uh, between 0.2, I mean 0 and 1.28, and I want to read the chart. You don't have to read the chart, but sometimes students want to read the chart. So first of all, you tell yourself which one is greater. 0 is, I mean, 1.28 is greater. So Z, the greater one, Z greater 1.28, because you're looking for area between, minus Z, the smaller number, Z0, and you subtract. You subtract. So watch me find the area of the greater part. So I'm going to go to the chart. So I'm looking at the chart now, and that greater number, and the greater number right there is that greater number is 1.28. So I'm looking for 1.28. And I am going to keep on looking for a positive number, 1.28. So I want you to see that this is 1.2 already, 1.2 right here, okay? So this is 1.2, 1.20, 1.21, 2, 3, 4, 5. I'm not there yet. This is 5. So I will keep on going. So I'm going to keep on going. So this is 1.2, 0, 1, 2, 3, 4, 5, 6, 7. So I need one more. So that's 1.2, 0, 1, 2, 3, 4, 5, 6, 7, 8 somewhere. Okay, I'm going to draw a line here. So I'm going to draw a line. Okay. And I keep drawing that line. Okay. So 1.20, I'm drawing this line on 1.2, so everybody should know where we are. But I'm looking for 1.28. So, but I haven't seen it. I have to find it. So the first one is 1.20 right here. This is 1.20 here. 1.20. So I'm arrowing to the back because I need to find 1.28 on the right hand side. So 1.28 is 89.97. So 1.28 is actually right here, 89.97, almost 0.9 here. So that is 1.28, 1.28. So I have found that, and then I can just 1.28, and then I find 1.0. So if I have this, I subtract the 1.28 from 0. Of course, Z of 0 is 50%. Let me pull that up again. That way, I want to make sure that everybody get it. So 1.28 is 0.8997. Okay. Okay, so this is 0.8997, 0.8997. And then Z of 0, we already know is 50% of, the mean is 50% of the normal curve. I will now subtract what 8 minus 5 gives me 3, and that's 3997, approximately 39.97%. Approximately. So the area between is 39.97%. So that's how to read the chart. It's not even difficult. That is how to read the chart. If you want to read the chart, you don't have to. You can use your calculator or use empirical rule or read the chart. There are three things you can do: use your chart, use the calculator, or use the chart. So let's go up and calculate in um, -1 and 1. So I can also, I'm going to read that with charts. Suppose I'm given a normal curve right here, and I actually want to make sure that the empirical rule is correct. I want to read the chart to show that the empirical rule is correct. So I'm going to be finding area within -1 and 1. So I will do z of the upper bound, z1, minus z -1. That's what I'm going to do. So I am going to read the chart now. I'm going to get the chart. So get the chart, and I'm looking for Z1. So what is Z1 right here? Z1 is 0.8413. 0.8413. So I come over here and write 0.8413. All right. And then I'm going to find Z -1. In other words, I'm going to subtract. So let me find Z -1. I'm reading the chart. We have already done it with calculator, but we need to know how to do it with calculator, with charts, uh, with T-table. I'm talking about Z-table, and with empirical rule. All right, so now I want to find, oh, why am I putting my calculator? I should be getting the chart. All right, let me get the chart right now. So I'm looking for Z -1. I already found Z1, and Z1 is 0.84 right here. It's 0.84 13. So I'm going to pull up and look for where -1 is. And this is -1 right here. Let's go up. -1 is right here. Okay, so I want to find what does -1 hold? 0.1587. 0.1587. So I am about to subtract 0.1587. All right. 0.1587. I want to verify the empirical rule. So I'm going to subtract. 15 minus 7 is approximately 8 here. And if I bring 1 from here, I have 10 minus 8, I have 2. And then I have 13 minus 5 is approximately 13 minus 5 is approximately 8 also. And then 7 minus 1 is 6. What am I trying to verify? I want to verify the empirical rule. Does the chart get the something? Yes. So using the chart, the area under the normal curve within one standard deviation, within means plus or minus, within one standard deviation is 68.28. Using the empirical rule, area under the normal curve within one standard deviation is 68% approximately, according to empirical rule. Using my calculator, the area under the normal curve is 68.28. So you should know how to use all three of them. You should know how to use empirical rule. You should know how to read the chart. You should know how to use the calculator. And this is in the test already, because empirical rule is in the test. Z-score is in the test. So you should know how to use this. This is a review, but I wanted to use real world examples to make sure that everybody understands empirical rule and understand how to apply it, understand how to use it with chart,